Everyone. Again, we are with a new episode for our Arabic NLP series, and today we are going to discuss information retrieval. As we know, this topic is not an easy topic in NLP, and people are doing a great job to enhance the information retrieval in general, and we got that new concepts of retrieval-augmented generation. Of course, it is not new, but I mean people start improving this concept with different algorithms, with different techniques, in order to make the information retrieval better and better for different languages. But for Arabic, still we have uh, some problems or issues, or let's consider it just challenges to make a fully Arabic RAG pipeline, let's say. First of all, when we discuss the semantic embeddings that are specified for Arabic, because if you notice, we have different versions of embeddings that are trained on Arabic, but they are trained on general text. Okay, some of it like based on English or multilingual context. So making it like very or less effective for Arabic specific applications. And also, Arabic is complex morphology, syntax, it has rich semantics. So we need a good embeddings that understand the context in a semantic way in order to prepare it for information retrieval, I mean. So the question now, can we build a fully Arabic RAG pipeline? And this is something I have been trying to improve this field of Arabic RAG. And yeah, there are many of the challenges, which the main one is we have a lack of open source Arabic generative models. We can see now most of the retrieval augmented generation pipelines uses like OpenAI, GPT-4 for Omni or Claude, or Gemini from Google, based on their API, and then they use it for different languages while they are primarily for English, right? So it works for Arabic. It's work great in Arabic, of course, but still we don't have the open source Arabic generative models that are capable to perform the task or to be comparable with OpenAI or Claude. So we have some, of course, there is cost. We have like limits in flexibility and also privacy concerns. That's why uh, we need or we have that lack. Now, of course, integration across components, because in retrieval augmented generation, we have that retrieval part and the generative part, right? And people now adding like the re-ranker or re-ranking parts. So this is like a full pipeline for, and each of these components must align in terms of input and output formats so it can give like good accuracy. Okay. And of course, if you do that integration in a wrong way, it ends up with no, ends up with model that cannot retrieve the context and cannot answer the user's questions, of course. Now, before I go deep about Arabic RAG pipeline, so retrieval augmented generation is how we combine the retrieval systems, the ranking techniques, and also the generative models in order to provide precise context-aware responses to user queries, right? So we have these three components, which is retrieval to identify the relevant documents of text chunks, and we have the re-ranker, which enhance the quality of the retrieved documents by like making uh, re-ranking, or if we have like for example four different retrieved documents, it starts making the most relevant one in the first so it can be seen by the generative models in order, and this is lead us to the third component, which can produce the coherent and the context aware and accurate responses. Okay, so how we can adapt these three components in order to get an Arabic RAG pipeline. Of course, we discuss these unique challenges, and also uh, we need the Arabic RAG pipeline because it will advance the question answering in Arabic. It might improve also the content summarization, and also the most important that we need accurate information retrieval. I have proposed this like last month or more than a month, discussing some of these components that I have developed some of them. For example, for the retrieval and for the re-ranking, we have state-of-the-art models that can be able to understand the Arabic in a semantic way, as I discussed earlier. I left the Arabic LLM as a question mark because the lack that we have seen in this field, but still, we can manage it somehow by using GPT models, right? So yeah, this is the pipeline that we are trying to do, and I think with a really good Arabic LLM that designed or trained on on information retrieval for Arabic, we can complete that pipeline. So let's discuss some of these parts, and then we are going to see some demo about this. So the first component discuss the Arabic retrieval system, which is the one that retrieve relevant documents from a large corpus by using semantic embeddings. So Gate Arabic version 1 is one of the models that we worked on to improve the Arabic embeddings by introducing some semantic meanings for this. So we have trained this model to understand the semantic and also to be able to do retrieval, right? So there is one technique called that called nested embeddings or matryoshka embeddings, where you fine tune the embedding model on triplet data sets that includes the query, the positive, and the negative. So in the training process, we are trying to make the positive and the query with a very minimum loss, I mean, and also making it from the query and negative with big error, right? So by this, we can make the model to understand the positive related to the query and refuse or get the negative can understand it and like just get rid of it. So uh, also, it could be also trained on multitask step, okay? So using different type of loss, you can like introduce the triplet, the retrieve dataset, and any different task. So you can adapt the model or the embedding model to understand these downstream tasks, okay? So we introduce Gate Arabert, and Gate Arabert is doing really great in terms of information retrieval, and it's reaching almost 40K downloads all the time, which really enhance the semantic similarity task, especially when we talk about STS or semantic similarity tasks. And of course, if you visit this embedding model, you can find a lot of details with the whole benchmarking and data sets, right? Then we can combine the retrieval with the re-ranker in order to make a good the first part, I mean, for the RAG to making like effective and produce really accurate relevant documents. So we can combine or integrate the retrieval with the re-ranking, and the re-ranking is uh, we introduce it's called ARA Reranker version 1, okay, and it's also based on the gates, but it is trained to understand the positive that related to the query, but also it has been trained on 4 different negative samples, okay. So by this, and yeah, we call it like data set that were positive, and we call it hard negative for robust learning, of course. Okay, and of course, when it comes to re-ranking, we are dealing with cross encoders, right? not the same in the retrieval, which is we deal with by encoders. So also I left some notes about the cross encoder in the page or the model card of this model. Okay, so you can visit it and read more about it. So the cross encoder architectures for direct query passage relevance scoring. Then we discussed about generative Arabic LLM, which is the third component, which is the one who produce or gets the accurate responses from the retrieved data. Of course, we have limited availability of open source Arabic LLMs, and we are depend or rely on GPTs and Claude to do this task. We have like emerging solution, and we have like an Arabic or potential open source Arabic LLM which called ALLaM, and I have some experience with that model, and I have used it for a competition, and I have used it especially for RAG, and it has like this. I like it in the retrieval because if it will be like open source, we can benefit from it to complete that pipeline, right? But the limitation until now, it is not open source, but hopefully it will become like open source soon, so we can have like to develop open source, or let's say to develop like complete or fully Arabic RAG pipeline. Okay, so yeah, this is the integration requirements, because we need to have the integration between the retrieval, the re-ranking, and the generation model. And of course, we need to keep the eye on optimizing it for real-time performance. And of course, we need some evaluation matrix that are specified for Arabic in order to evaluate these models, right? So the pipeline, as I showed you in the figure, and also here it is written, so input, retrieval, re-ranking, and generation. Okay, so there is an implementation that I have done in the blog post, and I am going to go through it quickly. So we have used the Gate Arabid version 1 as a retriever, and then we have used RMV1 as a re-ranker, and we used GPT-4 Mini as a generative model. Okay, and then we give it like a data set, Arabic data set with context, with some context, and we asked the pipeline about this documents, and we got the answer. So before I move to the demo, this is some of the potential or what the future of Arabic NLP, especially in information retrieval. So we are looking for, of course, democratization of Arabic language AI tools, and of course, it should be like open sourced. I mean, accessible for researchers and developers in order to use it, and then we can apply it on different applications in education, healthcare, business sectors, and others. So here's like a call to action, because we need to build open source Arabic elements, and I know some entities now are working on the information retrieval for Arabic, and we have like big future coming in this part. So yeah, there is a blog post. If you, I am going to go through it now, and also if you are interested in, you can just search about it, and I will leave like the link on the description, right? So here we go. We can see now the blog post that was published in November, and yeah, it starts with some question if we can build that RAG pipeline. And here, as I have discussed about what we have done so far in that field. Okay, so if we go to the demo now, I have used like there is a hands-on guide using framework, LangChain framework, and it used the re-ranker and the retrieval that we showed you, and also GPT-4 or GPT-4 Mini. Okay, so we have a data set with 2-page Arabic PDF, and we have used these component, let's say. So we start basically, let me just zoom in. So we have used LangChain to load that PDF file, and of course we need to give it the path, and then we have split the document into chunks, and now this is very unique or special, and you need to focus here, because we are not going to split these chunks into like character based, right? So you define the chunk size and the overlap size, and then it will go and do the chunking part. Now we are using what's called semantic chunking, okay? And this is a really great idea because it will do the chunks based on the semantic of that context. So if we have two page of PDF file, and it like has different context in different lines and different paragraphs, it will go and chunk them into different chunks or groups that carry the same semantic meaning. So this is really a great way in order to build the Arabic pipeline, and we have seen like a really great performance when we do the semantic chunking. And of course, we have used this model in order to do so. Okay, then we have like stored them in a vector store. We have defined the vector store as retrieval, and it is like K3. So we can retrieve 3 documents. Okay, then after we have the retrieved document, now we can introduce the re-ranking. So the re-ranking here used like we call it like in LangChain, we call it Hugging Face cross encoder in order to load that encoder or cross encoder. And then we use the cross encoder re-ranker in order to define that model. And then we can combine or to get the retrieval, the base retrieval that we use with the compressor in order to be able to do the re-ranking. Okay, so this is how we do the re-ranking part. Now we can generate the final answer using GPT or chat OpenAI from LangChain, that you can define different parameters for that function, so you can use it for generation. The good thing now, if you notice, we have like an Arabic prompt, right? So we don't need to do the English prompt. No, we are trying to do fully Arabic. So yeah, it is good to introduce some special tokens here for the end, the beginning of the sentence, some of it for the system, and this is for the user, and the assistant will go and generate the answer. But here we just told the generation or the LM that you are a helpful assistant that can answer in Arabic, okay, and in a clear way without any additions. So yeah, you can do the prompt like this, and then you have the chain. So the chain will of course take the context from the compression retrieval, which is the one that comes in the re-ranking, right? Then we will pass the query, and with the prompt and the LM, we can parse the output and we can print it right away. So we have asked this question, and it goes for it retrieved 3 different contexts or documents. Of course, you can see the metadata, and then it's re-ranked the context, and it ended up with the right answer here. Of course, this is like a general, this is one of the questions, and of course, we have done like different questions in order to improve or to see the performance of this, and actually, it gives like good results, very good results, I mean. And I put some key differences between the retrieval and the re-ranking so people can understand more about it, right? So yes, that was for this demo, and uh, we have a good potential to improve this RAG pipeline by getting uh, maybe an open source Arabic LLM that trained for retrieval. So back to our presentation. That was everything for today. I hope that you find this is useful, and I recommend that you go and download and start exploring more. Thank you.